I'm going to introduce you to a method of problem solving in chemistry called dimensional analysis, and this will be the technique that you use for all of your problems in chemistry. Dimensional analysis is a method of problem solving. There are certainly many methods to solve problems. This is just one of the best methods of problem solving, and particularly a good method for chemistry problems. In most of your chemistry problems, all you're really doing is converting one unit in a problem to another unit. And you do this by using a series of conversion factors. And we'll define what conversion factors are shortly. The steps in dimensional analysis are first to identify your starting and your ending units. It's your units that control the setup of your problem. So again, we've already discussed the fact that in chemistry you must put a unit on your measurement, so your units will control how you set up your problem. Once you've identified the starting and ending units, you will line up these conversion factors so that your units will cancel out. You then will take and multiply all of the numerators in your conversion factors and divide by the product of all of those denominators, and you will have your final answer in the correct final ending unit. The final step is to check your answer and your final units to make sure they agree, make sure you've done the calculation correctly, and that your units are correct. So again, it's just as simple as taking what is given in the problem and multiplying it by a series of these conversion factors. But we need to make sure we define exactly what these conversion factors are. So a conversion factor is nothing more than an equivalency statement set up as a ratio. And the way that you set the ratio up is determined by what unit you are looking for and what unit you are given. If 1 inch is equivalent to 2.54 centimeters, then placing 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch gives us an equivalency or conversion factor that's equal or equivalent to 1. So that if we multiply our original value by this equivalency, we have the same quantity variable, we simply have a different unit. In other words, we have the same amount of stuff, just in a different unit. So if we wanted to convert from centimeters to inches, we would take the given 60 centimeters and we would set up our conversion factor so that the unit we're not interested in, centimeters, cancels, and we end up with our answer in inches. The same conversion factor would be used if we were given inches to start with in the problem and asked to convert to centimeters, but this time we would flip the arrangement so that inches would cancel, leaving us with our final answer in centimeters. Let's look at a problem that really has nothing to do with chemistry, but just a basic measurement problem. We want to know how many milliseconds there are in 1 hour. And I understand that you think that there are many ways you could solve this, and I agree with you 100%. Obviously, all you're doing is multiplying by these conversions. But with chemistry, when the problems get more and more complex, having this logical way of setting them up, is going to help keep you focused. So we're starting out with what's given, 1 hour. We're going to milliseconds, so we need to end up with milliseconds on the top when we're done. We then pick our conversion factors to get us there. Here we know that 1 hour is equivalent to 60 minutes. If we stop the problem here, we would have the unit in minutes, but we want to keep going until we get to milliseconds. Our next conversion factor is that 1 minute is equivalent to 60 seconds. minutes on the bottom would cancel, leaving us with seconds on the top. And then our final conversion factor, 1 second, is equal to 1,000 milliseconds. Seconds would cancel. When we finish, our final answer will be in the unit we want, milliseconds. On our calculator, we would take 1 times 60 times 60 times 1,000, and then of course divide by the product on the bottom, which is a 1, so that would not be necessary, and that would give us our answer in milliseconds. You will often see in books this setup for the problem rather than taking and multiplying. It's exactly the same thing. It's just if you know you're going to have a long series of conversions, it's sometimes just a little easier to draw this long line and put your conversion factors in as you go along. 1 minute, 60 seconds, 1 second, 1,000 milliseconds. That's just a little easier than 1 hour times 1 hour, 60 minutes times 1, and so on. But either method is perfectly fine. What you need to make sure is that your setup is correct, that your units on the top and bottom are canceling, that what you've written is a true statement, 1 minute is equivalent to 60 seconds, and that you end up with the final unit that you are looking for. In our next problem, we're going from milliseconds to centuries. Starting with milliseconds, we know there are 1,000 milliseconds in 1 second. There are 60 seconds in 1 minute. There are 60 minutes in 1 hour, 24 hours in 1 day, 365 days in 1 year, and 100 years in 1 century. Doing the calculation would give us 3.17 times 10 to the negative 12 centuries. Now, students often want to combine these conversion factors by doing a calculation and saying that, well, I'm going to go ahead and say 60 times 60 minutes in an hour, but you really don't want to have to calculate any of your conversion factors. You simply put them down as they come to you or as you look them up. There's no need to do a calculation to come up with another conversion factor. That just leads you to error and chances for making mistakes. One last problem. How many milliseconds in 20 years? The question, simplified, 20 years equals how many milliseconds? We know this is what our final unit needs to be. This is our starting unit. In between our starting unit and our final unit, we have our conversion factors. Again, 1 year equivalent to 365 days, 1 day equivalent to 24 hours, 1 hour equivalent to 60 minutes, 1 minute equivalent to 60 seconds, and 1 second equivalent to 1,000 milliseconds. And after we do the calculation, we get 6.307 times 10 to the 11th milliseconds. There are other possible conversion factors you could have used. Students will sometimes go from years to months to weeks to days. That would certainly be fine. It's a little more time consuming, and your answer is going to be slightly different because of the different roundings and the different conversion factors. But it really makes no difference the path that you get there, as long as your path is logical and your units cancel and you end up with the correct value. You'll have plenty of practice with dimensional analysis before you start applying it to chemistry problems.